Good morning, guys. Today we are going to be going over how pulleys work and talking about the mechanical advantage of pulleys. Then we will get set up for tomorrow's demonstration experiment. So I'm going to read through this. You are welcome to mute me and read it on your own if you prefer. So in your investigation so far, we haven't done it yet, you've discovered that pulleys can be used to reduce the force needed to lift a load. Now it's time to learn more about how pulleys work. As you read through this information, keep a list of any words that are new to you. You've learned that the effort needed to lift an object is an example of a force. Gravity is also a force. It acts on all objects on Earth, including you, attracting them toward the ground. Gravity keeps you from floating into space. The weight of an object is a measure of the force of gravity acting on it. This is called the load force. In order to lift an object, you must work against the force of gravity. This is called the effort force. So the comparison of the load force to the effort force needed to lift the load is called the mechanical advantage. A fixed pulley can help you lift a load by allowing you to pull down on a rope. Pulling down is easier than lifting up a load by yourself. Imagine you had to move a refrigerator to the third floor of a building. Using a pulley to lift the refrigerator is much easier than carrying it up 3 flights of stairs. Although hopefully you have an elevator, which of course works by using a series of pulleys. Okay, so a fixed pulley, there's a picture of it right there. With a fixed pulley, when you pull down on the pulley rope, the load moves up. A fixed pulley changes the direction of the effort force. This means you can use your whole body to pull down to lift the load. So with only one pulley, however, the effort force is equal to the weight or the load of the object. So in that case, you get a mechanical advantage of 1, as we talked about earlier. Okay, so the single fixed pulley is fixed to something like the roof in this particular situation. And literally with this one pulley just changes the direction of the force. Okay, so here we have a movable pulley. With a single movable pulley, the pulley is attached to the load and the rope is attached to the ceiling. To lift the load, you pull up on the other end of the rope. So the effort force is in the opposite direction to the load force. The benefit of a movable pulley is that you only have to pull with half the effort. Sorry, I lost my thought. To lift the load. This is because the rope attached to the ceiling takes half the weight of the load. So if you look here, you can see that there are 2 ropes supporting the load. That gives you a mechanical advantage of 2, which is why you only have half the effort force. Okay, so if you look up here, only this one rope is supporting the load. This one, the pulling, because of the way you're pulling it, doesn't give a mechanical advantage. Just this one rope is supporting the load. In this case, you can see that 2 ropes are supporting the load. Therefore, this one, even though there's only one pulley, has twice the mechanical advantage. Okay, now we have a combined pulley. So in this case, we have a single fixed and a single movable pulley. Okay, so a combined pulley system uses both a fixed pulley and a movable pulley. The fixed pulley in the system changes the direction of the effort force, which we know makes it easier. We have much stronger pulling muscles than we have pushing muscles. So this allows you to pull down to lift the load. The movable pulley in this system over here lets you pull using only half the effort force. So this is because the pulley rope takes half the weight of the load. So in this case, you still only have 2 strings supporting the load. The mechanical advantage here is still only 2, the same as up here, 1, 2. But you also get the advantage of pulling down. Okay, so the mechanical advantage is still 2. The effort force is half, but you have the bonus of being able to pull down on the rope instead of pulling up. Okay, so here I have some questions. A pulley system makes it easier to lift a load because it can A, change the direction of the force needed to pull, B, reduce the force needed to pull, in this case the movable pulley, and C, change the direction of the force needed to pull and reduce the force needed to pull. which is the combined pulley. Okay, so here are some questions I'd like you to try. What is the advantage of a single fixed pulley system? What is the advantage of a movable pulley system? What is the disadvantage of a movable pulley system? Look at the picture of the combined pulley system. What type of pulley is the upper pulley and the lower pulley? And if you had listened, I gave the answer. And what are the two advantages of the combined pulley system? Okay, so here I am moving on to mechanical advantage in pulleys. I talked a little bit about it there, but a pulley provides an advantage because it changes the direction of the force, so pull down instead of lift up. A simple way to determine the ideal mechanical advantage, and that means not accounting for friction, of a pulley system is to count the number of lengths of rope between the pulleys that support the load. So for example, in this case right here, I have a single fixed, and you can see that the load force and the effort force are the same. Whereas in here, the movable pulley, the load force is double the effort force. So the mechanical advantage is 2. All right, so I'm going to post the textbook pages for Investigations with Pulleys 2.4, and I'd like you to create a hypothesis for the experiment. I will post the demonstration of the experiment tomorrow, and the pages will be posted separately. I already said that. Okay, so how does the number of pulleys in a pulley system affect mechanical advantage? If I increase the number of pulleys in a pulley system, then the mechanical advantage will do something because. So tell me why. Okay, so I've already done the independent variable here, increasing the number of pulleys. You're going to tell me the answer to the dependent variable, and a scientific reason. I'm going to do a bunch of different types of pulleys, which you will see when you read 2.4. Come up with a hypothesis, and I'll see you again tomorrow.